Hello and welcome to Engineers Mindset Academy. So in the previous video on thin shear cylinders, we derived the equation or the basic equation for a thin shear cylinder with hemispherical ends, and we also talked about the hoop stresses, the longitudinal stress, the radial stress, and the maximum shear stress in that video. Now in this particular video, which is the second video, we are going to be using those equations to solving real life problems. Now let's consider the question on the board. The question says a gauge pressure in a boiler of 1.5 meter diameter and 12.5 millimeter thickness is 2 kilonewtons per meter squared. Find the longitudinal and circumferential stresses. Now, in the previous video or in the first video, I said that to calculate your hoop stress can also be called the circumferential stress. So simply hoop or circumferential stress is simply by making use of the formula pressure times diameter all over 2 times the thickness. And to calculate your longitudinal stress, sigma L, we simply make use of the formula pressure times diameter all over 4 times the thickness. Now, the diameter was given, thickness was also given, thickness from there was given as 12.5 millimeter in the question. So we simply convert this to meters by dividing 12.5 with 1000. So this simply will give us 12.5 by 10 to the power of minus 3. Dividing that value with 1000, it converts it to meters. Now let's plug these values into the equation, not forgetting we are given diameter to be 1.5 meter and we are given the pressure itself to be what? 2 kilonewtons per meter, and 2 kilo simply means 2 by 10 to the power of 3 newtons per meter squared. That is what kilo stands for. That's the pressure. So if you plug these values back into the equation, we are going to find out that the hoop stress or the circumferential stress is simply equal to, we said pressure times diameter, and pressure is 2 times 10 to the power of 3 times diameter. Diameter remains 1.5, okay, all over 2 times the thickness. So it becomes 2 times thickness, which is 12.5 by 10 to the power of minus 3. Now this is going to be equal to, so 2 times 1.5 is 3, so you have 3 by 10 to the power of 3 divided by 2 times 12.5 gives us 25 by 10 to the power of minus 3. Okay, so we simply evaluate 3 by 10 to the power of 3 divides 25 by 10 to the power of minus 3, and this will give us, this simply gives us 120,000 in newtons per meter squared. All right, so this is the circumferential or the hoop stress for that given problem. The next thing we should find the longitudinal stress. The longitudinal stress, as earlier mentioned from the formula, is pressure times diameter divided by 4 times the thickness. Pressure itself remains 2 by 10 to the power of 3 multiplied diameter is 1.5 all over 4 times 12.5 by 10 to the power of minus 3. So this is equal to, once more, 3 by 10 to the power of 3 all over 4 times 12.5 will simply give us 50 by 10 to the power of minus 3. So we evaluate now. 3 by 10 to the power of 3 divides 50 by 10 to the power of minus 3. That gives us 60,000 newtons per meter squared. All right, so this becomes the value of the longitudinal stress. All right, so we have this. And also, not forgetting, in the previous video we mentioned that the hoop stress, okay, in the previous video we mentioned that the hoop stress or the circumferential stress is always given as 2 times the longitudinal stress. And if we try to compare that with this value, we have this value for longitudinal stress as 60,000. That means this is going to be what? 2 times 60,000, and this will also give you 120,000 newtons per meter square. So in most cases you might not need to solve. If you're able to find the longitudinal stress, then you can find the hoop stress and of course the maximum shear stress. Now if we are asked to find the maximum shear stress, in the previous video I also explained that the maximum shear stress itself is always given as 1 all over 2 multiplied by the longitudinal stress, simply the half of the longitudinal stress gives us the maximum shear stress. So which means if we are asked to find the maximum shear stress here, it is simply what? 1 divided by 2 multiplied by the longitudinal stress itself is 60,000. So multiply by 60,000. So this simply means that the maximum shear stress between these two principal stresses is 30,000 newtons per meter squared. All right, so that's how to find the hoop stress, longitudinal stress, and the maximum shear stress. Let's pick one more problem and then we can wrap it up on thin shell cylinders. Okay, so let's consider this other question. The question says a gas cylinder of internal diameter 1.5 meter is 30 millimeter thick. Find the allowable pressure of the gas inside the cylinder if the tensile stress in the material is not to exceed 10 meganewtons per meter squared. All right, so let's pick out our parameters. First of all, we are given diameter. Okay, we are given diameter D to be equal to 1.5 meters. We are given thickness. We are given thickness T to be equal to 30 millimeter. So divide again by 1000 to convert this to meters. It becomes 30 by 10 to the power of minus 3 in meters. All right, so we are to find the pressure of the gas inside the cylinder if the tensile stress in the material is not to exceed 10 meganewtons per meter squared. Now, please take note, whenever they use the word tensile stress in the material, I've told you that in a cylinder, there are three different types of stresses. We have the circumferential or the hoop stress, we have the longitudinal stress, and we have the radial stress. Now, amongst these three, the hoop stress or the circumferential stress is always the greatest. So whenever a question is given in such a manner, not specifying which of the stresses, whether hoop stress or radial stress or longitudinal stress, then always take it to be what? The hoop stress. So we are given that if the tensile stress is not to exceed 10 meganewtons per meter squared, then this simply stands for what? The hoop or circumferential stress. So simply take that as the hoop stress, and it is equal to 10 meganewtons per meter squared, which is simply 10. Mega simply means by 10 to the power of 6 newtons per meter squared, and we have this. Okay, so from the formula, hoop stress sigma h, remember, is given as pressure times diameter all over 2 times the thickness, and the question is asking us to find the pressure, so we need to make pressure subject of the formula from here. To do that, this is simply saying cross multiply sigma h, which is the hoop stress, multiplies 2 thickness divided by the diameter. That gives us the pressure. Okay, so pressure P is simply equal to 2 thickness times the hoop stress all over diameter. All right, now let's put in the values in the formula. This is equal to, okay, we can continue down here. So pressure is equal to 2 times thickness is what? 30 millimeter, which is 30 by 10 to the power of minus 3. So you have 30 by 10 to the power of minus 3 times the hoop stress, which is 10 meganewtons, and that is 10 by 10 to the power of 6 all over diameter, which is 1.5. So divide by 1.5. Now this is equal to, let's multiply the numerators all through. So everything at the numerator gives us 600,000, okay, divided by 1.5. All right, so that gives us pressure to be equal to, divide 1.5. That gives us pressure to be equal to 400,000 newtons per meter square. So the pressure of the gas inside the cylinder is simply 400,000 newtons per meter square. All right, guys, so that's how to apply the thin shell equations or formulas to solve problems. Thank you, guys. That will be the end on thin shells. In the next video, we'll come up with a different topic in strength of materials. Thanks and cheers.